I'm going to put this on. You're going to take this so I don't accidentally push the power button. Test is on Monday, yes. So, from before lunch, we are doing the integral from 1 to 4 of x squared minus x dx. Total width is 3. The width of each region is 3 over n, because we're dividing that entire width into n regions. So 3 over n. Your first tick mark is at 1 plus 3 over n, then 1 plus 3 over n times 2, 1 plus 3 over n times 3, up to 1 plus 3 over n times n. I wrote out my sum, but because we're taking the limit as n goes to infinity, I'm going to stick that up front. And then I converted this into sigma notation. So I have my sigma formula. And again, those of you not here, I'd kind of watch and kind of follow things, but I would then watch all of this stuff later so you can see the entire story. This is very similar to what we were doing yesterday. There shouldn't be huge jumps from there. So now, what's the function we're using? Proxy pass? Okay. Here's what you're going to do. You're going to go here. You're going to find your name, and then you're going to say restaurant. Okay, what's the function that we're using? X squared minus x. I'm going to go and I'm going to plug this thing into that function. I'm going to get the limit as n approaches infinity of the sum as I goes from 1 to n of 3 over n times 1 plus 3i over n squared minus 1 plus 3i over n. And now there's a lot of algebra. Take a few moments, do your foiling, do your distributing the negative, distribute the 3 over n, combine like terms, and let's see what we can do to clean up the stuff inside that sigma. Actually, at this point, I feel like this kind of looks like one of those infinite series problems. The beginning was the new stuff. Now it's just some algebra and some rewriting. So please do some foiling and keep going.
Is that 31 or 3i?
3i. We're doing algebra right now, right? We're doing the algebra part of the problem. We're foiling and combining like terms. Oh my gosh. But you're distracting people who aren't close to being done. Okay, keep working. You wait till Sophia gets back. Push the one that says end. Can we get 9i over n squared plus 27i squared over n cubed inside the sigma? I think at this point, you should be separating it into two different sigmas,
Oh no,
right? What's wrong?
this is hard. And it takes a lot of work.
Okay. I think I'm just going to do a limit before the whole thing, and I think that'll be good enough. So, let's see. This is the limit as n approaches infinity of 9 over n squared times the sum as I goes from 1 to n of I plus 27 over n cubed times the sum as I goes from 1 to n of I squared. I think you need to go to your formulas, plug those formulas in, do some foiling and stuff. There is no need to combine the two formulas. I would just do one problem over here, one problem over here, and then do the two separate limits. So see if you can keep going with this.
Wait.
I can. Bless you. Focus, please. Thank you. See if you can finish it off. Do your two separate infinite limits, add the answers together, and this is no longer an area approximation. This is the actual area under that function. Well, signed area under that function.
So we should put like the S, or wait, the...
So we could end it by saying the integral from 1 to 4 of x squared minus x dx equals the number you get. You can say that.
Big S.
Oh my gosh. No, he's talking about the integral symbol. He just doesn't remember the name for that.
It's big S.
We could either just say 27 halves, or we could say the integral from 1 to 4 of x squared minus x dx is 27 halves.
Does it have to be a fraction?
Yes.
No. Decimals are superior.
Questions on these things? You are going to try a couple of these in the homework. So for this quiz on Friday, which will be a little bit of a longer quiz because we haven't had one on 4.2, It's going to be the area approximation stuff, how we started, the right endpoint, some left endpoint, some midpoint, some trapezoid, some with 3 or 4 regions where you actually write them all out and do that. Yes, you'll have the calculator. Then you'll have a right endpoint sum with like 40 regions where you'll need to use sigma notation and all that. Then probably 2 of these things. By the way, I don't think I ever gave a name to what we're doing right now. We can call this thing the limit process because we're kind of finding a limit to kind of get us through all this stuff. Everything we've been doing here, I can call the limit process. So when you see that in the review packet for the test, on the quiz, on the test, that's what I mean. What? And there's one last thing we need to talk about called Riemann sums. And yes, we don't need to record the rest of this. I'm not going to hit the power button. Okay, I need to hit the one with the camera on it because there is no. Okay.